right, welcome to notes 5.4 to 6. And hopefully at this point we've done the remaining two constructions of our points of concurrency, so we can go right on ahead and do this summary. And the point of concurrency of the perpendicular bisectors of a triangle is the, go ahead and write it down right now, I'll wait. Did you say circumcenter? Because if you did, you're right. All right, what's the point of concurrency of the altitudes of a triangle? That would be the orthocenter. The point of concurrency of the angle bisectors of a triangle? That is the incenter. And the point of concurrency of the medians of a triangle is that's the centroid. All right, so those four are important. It's important that you know what the point of concurrency is called, what it's formed by, so whether it's formed by perpendicular bisectors, altitudes, angle bisectors, or medians, and also what the critical information about each point is. Okay, so which of these points can be located outside the triangle? The two are the circumcenter and the orthocenter, which means that the incenter and the centroid must always be located inside the triangle. That's also good information to keep in mind. Okay, let's talk a little bit about triangle inequality and the Hinge theorem. So in a triangle, the angles and the sides have a special relationship. Now, they're not equal to each other. They're not proportional. We're not going to ever write a proportion with sides and angles, but they do have a relationship. It's sort of an unequal relationship. I usually compare it to Bella and Edward, right? Because they're in a relationship, but they're not equals to each other. But now that Bella has become a vampire, ooh, spoiler alert, I guess they are equals. Okay, so I'll have to find another analogy. Maybe I can work a Hunger Games analogy into it. I'll have to think about that. Okay, so now that I've babbled, in a triangle, if one side of a triangle is longer than the other side, then the angle opposite the longer side is greater than the angle opposite the shorter side. So in this triangle over here, side AB is greater than side BC, right? This one is 8, this one is 5. So the angle opposite AB, which would be angle C, is going to be greater than the angle opposite BC, which would be angle A. And then there's kind of the flip of that. If one angle in a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. So I've got two angles, 50 and 20 maybe, which means that the side opposite the 50-degree angle is going to be greater, so side BC is going to be greater than the side opposite the smaller angle, which is going to be side AB. Makes sense, right? So what that means is if we know the angle measures, then now we know how the sides relate to each other. So this wants us to list the sides in order from shortest to longest. Well, the shortest side is going to be opposite the smallest angle, so QR is going to be my shortest side, and the longest side is going to be opposite my greatest angle, which means that PR is going to be my longest side, which means that the other side, PQ, must be my middle. So QR is going to be less than PQ, and PQ is going to be less than PR, right? Shortest to longest. And then furthermore, if I'm given a problem here, which says a boat makes a trip whose path has a side or has sides of 1.52 and 2.5, and then the angles are 90, about 53, and about 37, we need to sketch and label a picture of the trip route. Well, we should be able to figure out which angle is opposite which side. And since we know one of them is a 90-degree angle, then we know what we have going on here is a right triangle. So here's my right triangle. Whew. Maybe. Okay, there's my right triangle, which means that this is my 90-degree angle, and let's just say this is my 53. And this is my 37. I realize they don't look like that, but, you know, not to scale, right? Okay, which means that the longest side must be opposite the greatest angle. So this one must be my 2.5 mile side, and then this one down here must be my 2 mile side. And finally, this one, because it's opposite the smallest angle, must be my shortest side. So this one is my 1.5 miles. All right, beginning to see how angles and the sides relate. Not a difficult concept. Okay, let's move on to the triangle inequality theorem. So frequently I ask students, can you make a triangle out of any 3 sides? And they will tell me, yes, Mrs. Uken, I can make a triangle. If you give me 3 segments, I can make it into a triangle. And then they find out that that's not true. And here's the reason why. It's because the sum of the lengths of any 2 sides of a triangle must be greater than the length of the 3rd side. So what that means for our triangle ABC here is that AB plus BC must be greater than AC. And it means that AC plus BC must be greater than AB. And it also means that, oh, now I can't remember which ones. So AB, BC, AC, AB plus AC must be greater than BC, okay? All of that. So let's talk practical purposes. If a triangle has a side of 23 and another of 17, then what are the possible lengths of the 3rd side? Well, I know that if I, in my example up here, if I add them together, so 23 plus 17, it must be greater than the 3rd side. Well, 23 plus 17 is 40, which means that my 3rd side has to be less than 40. Okay, and then 23 plus something else must be greater than 17. Okay, well, 23 is already greater than 17, so we're good there. And it also means that 17 plus something else must be greater than 23. Okay, well, 17 plus anything greater than 6, right? If I put 6 here, they're equal, so anything greater than 6. So my 3rd side must be greater than 6, and it must be less than 40, is the conclusion that I can make here. Not greater than or equal to. Okay, there's no equal to, because it can't equal these 2 things. It must be greater than 6 in order to make these 2 sum greater than 23, and also it must be less than 40 because these 2 together only sum up to 40. Now, the way you can think of this in shorthand, if you don't want to kind of run through all the scenarios, is this is the difference of the 2 sides, and this is their sum, and then you'll always get your missing side is going to be in between the difference and the sum of the 2 sides that you are given. That's important. Remember that. Okay, so now we're going to talk about Hinge Theorem, and Hinge Theorem goes back to the concept that angles and the side opposite them are related. And the Hinge Theorem simply states if I have 2 sides of one triangle are congruent to 2 sides of another triangle, so this side's congruent to this side, and this side is congruent to this side, and the included angle of the first is larger than the included angle of the second, so now we're talking about what's true of the side opposite those. Well, clearly, the bigger angle is going to be across from the longer side. So the 3rd side of the first is going to be longer than the 3rd side of the second. So WX over here is going to be greater than ST. All right, so here I'm simply told that the measure of angle ADB here is greater than the measure of angle CDB. And that is the included angle, right? They share this side, so we've got 2 congruent sides, they share this side and the angle in between them, which means that if this angle is larger, then AB is going to be greater than CB, right? The angle opposite this one, I'm sorry, the side opposite the smaller angle. And that's all that Hinge Theorem is stating. All right, and then there's kind of the converse of that, which now says if I know that we have 2 pairs of congruent sides and I know what the length of the 3rd side is, what does that tell me about the angle opposite? Well, obviously, if my side is longer, then my angle is going to be greater. That's what the Hinge Theorem, the converse of the Hinge Theorem tells me. So let's look at this example here. If AD is congruent to BC and they share this side, so that side's congruent to itself, then what do I know about angle 1 and angle 2? Well, the side opposite angle 1 is greater then the side opposite angle 2, which means that angle 1 must be greater than angle 2. And that is how the converse of the Hinge theorem works. Okay, so a couple more examples. So in A here, we've got 45 is congruent to 45, and this is congruent to itself, and this side right here is smaller than this side right here, which means that 52, the angle opposite the longer side, must be greater than the angle opposite the shorter side, x plus 18. So that means that x must be less than 34. All right, you guys do B and come back when you have an answer. Hit pause now. Okay, did you get x is greater than 4? This one's a little tricky because you have to recognize that the triangles aren't quite oriented the same. So 12 is congruent to 12, 18 is congruent to 18, which means that this x is the side opposite the smallest angle, so it must be less than this side, 3x minus 8, which is opposite the larger angle. And if we set it up like this, 3x minus 8 is greater than x, then we get that x is greater than 4. Some more examples. So I would like you to tell me what the answer to this is in the notes check. This is going to use that triangle inequality theorem, so go back and look at that. And then I need you to tell me also in the notes check what the smallest angle is going to be of this one and the largest angle are going to be for each of these two triangles. And then again, I want to know what the shortest and longest sides are for these two triangles right here, all in the notes check. All right, please go do that, and I will see you in class. If you have any questions, be sure to speak up. Thanks.